everyone, it's Alyssa and welcome to Tricky Math Tuesdays. Today's tricky math problem comes from a tutoring student of mine. This was from an assignment he had and I thought it was interesting, and so I'm going to pass this on to you guys. All right, apologize for the slightly fuzzy nature. That's the best we had. So here's our problem. Two boats, J and K, are 500 meters apart. A lighthouse is on top of a 470-meter cliff. The base B of the cliff is in line horizontally with J and K. From the top T of the lighthouse, the angles of depression of J and K are respectively 25 degrees and 40 degrees. Find, correct to the nearest meter, the height H of the lighthouse from its base on the cliff top ground to the top T. Okay, there's two main ways to solve this that I can see. There's one way using something called the law of sines, and there's also a way just to do it using only tangent. That's it. And that's the one I want to show you, because law of sines is something that you usually don't see until you've been in trig for a little bit. So I want to start with something that they introduce even in algebra or geometry, just the sine, cosine, and tangent. Those three basic ones. So again, for a tangent, if I have a right triangle without a tail, and let's say this side is A, this side is B, and that side is C. And this angle right here, we'll go like, okay, this angle is, I don't know, 50 degrees. Then tangent says the tangent of 50 degrees would be the ratio of the opposite side to the adjacent side, or A divided by B. And tangent of 50 degrees is just a number that has been recorded in history. You can find it in your calculator. And we can use this to solve for A or B, or if we have A and B, we can figure out what that angle is. So that's your little refresher if it's been a while since you've used tangent. That's all we're going to do is the relationship between opposite side, opposite leg over adjacent leg, tangent. Okay, so first things first. I'm going to zoom in a little bit on this picture, even though it's fuzzy. There's actually two variables in this equation. There's two things we don't know. We don't know, well, of course, we don't know the height. That's what we're trying to solve. But there's another big one we don't know if we're going to use tangent. We don't know what this distance is. Why is that important? Because this distance is the same as this distance. And that's the part that's going to become important in just a second. I'm going to draw in a couple lines here to make some nice, if this ruler will cooperate. Come on. It's like, no, I don't want to spin nicely. All right, come on, there we go. All right, so I have this perfect little triangle. I'm also going to make one right here. Okay, so I have my red triangle, and overlapping it we have this purple triangle. They are actually overlapping. Okay, so I have red triangle and I have purple triangle. So red triangle, I'm using that little angle of depression. That's that triangle. And then purple triangle is this triangle right here. Okay, so we're going to look at these two different triangles. All right, first, red triangle. I have a 90-degree angle, and I have this angle over here, 25 degrees, as part of my red triangle. I go, okay, I need to find some sort of ratio. I have no idea what the length of this side is, the hypotenuse. So that eliminates sine and cosine. Those ratios always use the hypotenuse. So that's why I focused on tangent. Tangent uses the opposite side, which would be this side, this leg, and the adjacent leg, which would be this here. All right, so how do I represent these two? Well, the opposite one, this one over here, how tall is it? Well, I know it's 470, and then we've got the height of the lighthouse. So I'm going to call this 470 plus h. Okay, so what is the adjacent leg? Well, I know this bit right here is 500, but I don't know what this extra bit is. I'm going to call it x. So this whole side would be, and I'm going to write it up here, 500 plus x. Shame on them for not giving me more room to write on their picture. So that whole side, that whole top side for the red triangle here is 500 plus x. Okay, so I'm going to go over here and write for my red triangle, my little red triangle. I have my angle, 25 degrees, and I say the tangent of 25 is equal to 25 degrees, is equal to the opposite side, that's 470 plus h, over the adjacent side, which is 500 plus x. All right, on to my purple triangle. Probably should have made them like red and green or red and blue to make them stand out more. Oh, well, it can't be helped now. All right, so purple triangle. Here we have our purple triangle. Well, what's going on with the purple triangle? I've got this angle over here is 40 degrees. What is my opposite side? Well, it's the same as the red triangle. It's the height of the cliff, 470, plus the height of the lighthouse, so 470 plus h. Well, what is the adjacent leg? It's just x. So for the purple triangle, the tangent of its angle, which is 40 degrees, is the opposite side, which is 470 plus the height, over the adjacent side, which is just x. Okay, so I'm going to push this picture out of the way. I'm going to look just at these two problems. First, I'm going to look at this top one here. And I'm going to get rid of this bottom fraction by multiplying both sides by 500 plus x. So what happens then? We have 470 plus h over 500 plus x, and I'm going to multiply this side by 500 plus x, and I'm going to multiply this side by 500 plus x. Okay, so that cancels out on the right-hand side. And on the left, I have, 500 plus x times the tangent of 25 equals 470 plus h. Now I'm going to leave that alone for just a second. I'm going to move on to the purple triangle. Purple triangle. Go over here. Tangent of 40 equals 470 plus h over x. I'm going to multiply both sides by x. That cancels those out, and I am left with x times the tangent of 40 equals 470 plus h. Ooh. Here's what I'm doing. All that I'm doing right now is I realized, as awkward as they look, that I actually have a system of equations going. I have two variables, h and x, but I have two different equations. So I was trying to see, could I manipulate these in some way and get something interesting going? And look at this. Just by, scoot it over again, just by getting rid of those fractions, by making it a little neater, cleaner, easier to look at, something very interesting has happened. I have this quantity is equal to 470 plus h, and this quantity is also equal to 470 plus h. If they are both equal to the same thing, that means they're equal to each other, right? Because just to show you the logic of this, if I replace both of these with a number, like if I said a whole string of stuff is equal to, 153, and then I told you this whole string was also equal to 153. Oh, well, then these two things are equal to each other. They're both equal to 153. 470 plus h is just a number. So they are equal to each other. All right, so 500 plus x times tangent of 25 equals x times tangent of 40. All right, now it's time to solve for x. I'm going to ask my little handy dandy calculator, what is the tangent of 25? And it says, oh, thank you for asking so nicely. The tangent of 25 is, and I'm going to use all the decimals here that it gives me, 0.466308, because I'm just being fancy today. No rounding today. Oh, no, no, no. I don't like rounding to the end just to make sure. On the other side, the tangent of 40. Tangent of 40 is 0.8391. I said that's times x. Okay, so over on the left, I'm going to distribute and multiply both sides. And both of those terms would be the right way of saying that. Okay, so 0.466308 times 500 equals 200. I don't know why I switched to red. Let's go back to green. 233.154 plus, and I'm multiplying this part by x, 0.466308x equals 0.8391x. Crazy long decimals aside, this is a pretty standard algebra problem. It's like saying 5 plus 3x equals 4x. Solve for x. It's the same setup. A number plus some x's equals some x's. So I'm going to solve it the same exact way I would do that. I am going to subtract 0.466308x. I know it's absurd. I just don't like rounding before the end if I don't have to, because especially if you have a multi-step problem and you don't know how many steps it's going to be, and if you round early on, you can have some really large margins of error by the end, and you can end up getting things wrong, so I just don't do it. All right, so I get that 233.154. I'm sorry, it is getting kind of funny. It's like these numbers here. All right, so 233.154. Oh no, I closed my calculator. Don't do that. Equals 0.372792x. All right, so 233.154 divided by 0.372792 equals. Is it slightly ridiculous? Yes, it absolutely is. I'm sorry. X equals 625.426511. Okay. Now, going back over to either. I'm going to remember that number. I'm going to go over here. I'm going to rewrite it over here. Don't worry. I'm going to write it over here again. All right, so now I know that x is equal to 625.426511. I could probably start rounding at this point, but I've committed. So I can use either my red triangle equation or my purple triangle equation to figure out what h is. I'm going to use this one. And I already converted it. And in this step right here, I said that x times the tangent of 40 equals 470 plus h. So I'm going to plug it into there. So tangent of 40, we said is 0.8391. I'm going to multiply that by x, 625.42651. It is getting a bit ridiculous. I can't help myself. And so that is 524.795. I am going to round slightly because I know I'm right at the end. Equals 470 plus h. I should write that here too. Equals 470 plus h. I subtract 470 from both sides. Subtract 470. And I get that my height is equal to 54.795. Okay, and what did they want? They weren't wanting precision. Oh well, they wanted it correct to the nearest meter. So the height of this lighthouse to the nearest meter is 55 meters. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.